So this video is going to be talking about hyperbolas. We will be introducing the concept of asymptotes, and we would also be talking about lines of symmetry. Hope you guys like it. Stay tuned. Hyperbolas. One of the very important things you need to know about hyperbolas right off the bat is asymptotes. Asymptotes are imaginary lines in which your graph comes very close to but doesn't have the right to touch it. In our graphs, it's normally represented by a dotted line, just like what we see on the screen right now. The equation of a hyperbola looks like this. It is a over x minus p plus q, where the p and the q represents the asymptote, right? The p represents the x asymptote, while the q represents the y asymptote. Now, it's very important to note that the q as it is represents your y asymptote. And why I said this, why I'm specifically talking about this, is because if your q is 3, it means the y asymptote is y equals to 3. However, for p, you would always have a change in sign. So if your p is negative 2, it means that your asymptote isn't negative 2, it's actually 2. And the reverse could be said that if your p is positive 2, then your x asymptote will be x equals to 2. So let's talk about shape. The shape of a hyperbola looks like this if it is positive, and it looks like this if it is negative. Those dotted lines represent the asymptotes. Now, we normally say that for a positive graph, it's usually in the first and in the third quadrant, while for a negative graph, it's usually in the second and the fourth quadrant. Now, if you're wondering where does this quadrant comes from, a quadrant looks like this, where that's the first, the second, the third, and the fourth. So next up, we'll be drawing the hyperbola. We have the equation like the format we talked about a minute ago. Now we're going to use that formula to try to draw our hyperbola. Now also we'll be talking about line of symmetry. Line of symmetry is the same thing as an axis of symmetry. It is a line that divides your graph into two equal parts. And we're going to be using that to answer the questions that we're going to talk about right here. Okay, let's get into it. So the first question says you should write down the equation of the asymptote. Now for you to get the equation of the asymptote, your answer is always going to be x is equals to and y is equals to. Now x is usually equals to negative p, while y is equals to q. Now from this one over here, we can see that this negative 3 here is your q, meaning that this here is negative 3. However, we can see that our p here is negative 2. So it means that this here will be negative, open bracket, negative 2, which will make it 2. So our answers are x is equals to 2 and y is equals to 3. Now from this here, it tells us to sketch the hyperbolic function. Now for us to sketch our hyperbola, we need to do a couple of things. The first step we need to find out is to find our asymptote, and that's what we already got down here already, which is x equals to 2, y is equals to 3. The second step we need to take is that we need to find our x and y intercept. And how do we go about doing this? Literally by substituting, right? So let's do that real quick. Then we find the y-intercept. So these are your x and your y-intercept. So we have our asymptotes, we have our x, our y-intercept. Now we just need to put it into our points. So now the third step we need to take now is to draw. All we just need to do is plot the points we have. First of all, start with our imaginary line, our asymptote first. Then we plot the x and y-intercept, then we draw, okay? Now we have our asymptote drawn. There was a step I forgot to say at the beginning of this example, which is your A, which represents the shape. This formula has an a to be 8. That's what our equation is. And like we said earlier in the video, that whenever your a is positive, your graph is normally drawn in the first and in the third quadrant. And that's what we needed to draw here. So we're going to try connecting our points now. And that's it. Now, I do apologize for my graph looking crooked, but that's all they needed you to draw. And finally, the last question here asks us to find the lines of symmetry. Now, for us to get our lines of symmetry, what I like to do is I normally I use this to help me get my lines of symmetry. Those two values there, which is x minus 2 we have in our denominator and our q there to be -3. And to get our lines of symmetry, the formula that we use is, this first bracket is what we have here as x minus 2. And the q, on the other hand, is this -3 that we have here. So all I just need to do is start with the positive, then use the negative, and I should be able to get my answers. So with that, we can draw our lines of symmetry. To draw your line of symmetry, you will need to use linear functions. We talked about linear functions in earlier videos. You can check it in the playlist in case you're struggling with that. That's it. Now, what happens when you're given the graph itself, but you now need to find the equation? This example over here, we'll be talking about how we're going to run that process. This example here says the diagram below represents the graph of fx is equals to a over x minus p plus q. We're told that we have a point of t, which is 5 and 3. It's the point on your f, okay? And that's that point they're talking about over there. From here, I can see my asymptote is at 2, and there's also another one here is at 4. Now, the question here says determine the value for a, value for p, value for q. And before we move on too far, we should know that our a would be positive. Now, if we try to get any answer and the answer doesn't end up being positive, it means you're wrong. How do I know that? My graph is in the first and the third quadrant, so I definitely know it has to be positive. So the first things I can do to be able to find a, p, and q is to find p and q, because we do have our imaginary line, which is in yellow over here. So we understand that our q would be equals to 2, right? And the reason for that is because we see that that line crosses y equals to 2. And our p would be equals to -4. Now, the next thing we're going to do here is to put this into our equation. For us to be able to get our value for a, we need to substitute one other point that we haven't used in calculating so far. So we've used the 2, we've used the 4, but we haven't used this coordinate here for our t, which is 5 and 3. And that's what we're going to try to substitute to help us get our answers. And that's it. And finally, just one last thing I haven't said. It's about your domain and your range for your hyperbolas. We say that our domain is usually the element of real numbers, but it doesn't include your asymptote. While the range is the same thing, it's an element of real numbers, but doesn't include the asymptote. If you have any questions, you can direct it to the comment section below. There is a playlist of other function sections that you guys might be having problems in. Please check it out. Please don't forget to like and subscribe. Bye.